Real-world text is messy. It comes with punctuation, numbers, extra spaces, HTML tags, and words that add no meaning. If you feed that noise directly into a model, your model learns from the noise. In this episode, we go line by line through every cleaning step you need to build a solid pre-processing pipeline. Raw text scraped from the web or collected from users is almost never clean. It contains HTML tags, URLs, emojis, and inconsistent casing. The word Python with a capital P and Python with a lowercase p are the same word, but a model that has not seen lowercasing applied will treat them as completely different tokens. Punctuation, numbers, and common words that carry no meaning all dilute the signal your model needs to learn from. The quality of your pre-processing directly determines the quality of your model. Lowercasing is the simplest and most universally applied cleaning step. Python's built-in lower method converts every character in a string to lowercase. Without it, the same word spelled with different capitalizations is treated as multiple distinct tokens. NLP, NLP, and NLP would be counted separately. With lowercasing applied, all three map to the same token. Always apply this as your first cleaning step unless your task specifically depends on casing, such as named entity recognition where capitalization carries meaning. Punctuation rarely contributes to meaning in text classification or sentiment tasks. The string module in Python provides a punctuation constant that contains every standard punctuation character. The makeTrans method creates a translation table that maps every punctuation character to nothing. Passing that table to translate applies the removal to the entire string at once. The result is clean text with no punctuation marks remaining. Note that for some tasks like question detection, punctuation like the question mark does carry meaning and should be kept. Numbers are often noise in text classification tasks where the numeric values carry no semantic meaning. We use the RE or regex module for regular expressions. The pattern \D+ matches one or more consecutive digit characters. The sub function replaces every match with an empty string. After removing numbers, gaps of extra whitespace are left behind. A second regex pass using \S+ replaces any sequence of whitespace characters with a single space, and strip removes any leading or trailing whitespace. Stopwords are common words like the, is, a, of, and this, that, which appear in almost every sentence but carry very little meaning on their own. NLTK provides a pre-built list of English stopbots. We download it, convert it to a set for fast lookups, then filter our token list using a list comprehension. Only tokens that are not in the stopbot set are kept. The result contains only the content-bearing words: simple, example, stopword, and removal. In many classification tasks, removing stopwords significantly reduces noise and speeds up training. Text scraped from the web often contains URLs and HTML tags. Both are noise for most NLP tasks. To remove URLs, we use the regex pattern, HTTP followed by \S+, which matches HTTP and everything after it, up to the next whitespace character. For HTML tags, the pattern less than $? and the greater than symbol matches any HTML tag. The question mark makes the match non-greedy, so it stops at the first closing angle bracket rather than consuming everything between the first opening and the last closing tag. Here, we combine every cleaning step into a single reusable function called preprocess. It takes any raw text string and applies the full pipeline in order. First lowercasing, then URL removal, then HTML tag removal, then number removal, then punctuation removal, then tokenization, then stopword filtering. Finally, we join the remaining tokens back into a single clean string. Wrapping everything in a function means you can call it on any text in your dataset with one line of code. This is the standard pattern for building NLP pre-processing pipelines. Pre-processing is a custom build, not a universal template. While removing stopbots aids sentiment analysis, it sabotages named entity recognition, or NER, by erasing boundary markers like the. Similarly, lowercasing destroys the capitalization signals that differentiate London, the city, from informal usage. Because overcleaning can strip away vital task-specific vocabulary, you should inspect each step's output individually before finalizing your pipeline. Ultimately, design your pre-processing to serve your specific objective rather than following a generic recipe. You now know how to clean raw text for NLP. lowercasing, removing punctuation, numbers, stop-ops, URLs, and HTML tags, and how to combine everything into a reusable pipeline. In the next episode, we cover stemming and lemmatization, where we reduce words to their root forms to further reduce vocabulary size. If this helped you, subscribe so you do not miss the rest of the series.